Hello, good evening, good afternoon, good morning, good afternoon, whenever you're watching this video. Sorry that I'm not able to be there today. This is a Mr. Lewis AP Statistics video. We have section 9.3. I thought it would be a great idea to not waste this opportunity to actually do this section because things are just going to keep moving fast. And this is not a heavy lift by any means. So this should be a quick video that you can watch today and then continue on with working on 9.1 or 9.2. We are doing significance testing, hypothesis testing. And today we're just going to look at this is the same sort of procedure, sort of path as in chapter 8, where we looked at the difference in two things. So we did confidence intervals with a difference between two proportions, so some subtraction. And now we're doing a test about difference of proportions, some subtraction. So we have two different groups, two different claims, two different what am I trying to think of? Two different sample proportions, and we're trying to see if there is a difference between them. And so, right off the bat, what we always claim as our null hypothesis is that P1, P sub 1 minus P sub 2 is equal to 0. That means that they are the same, that the proportion in the two groups is the same. The proportion of people that are able to make a trash can basketball free throw in period 3 is the same as in period 1. That's always going to be our null hypothesis when comparing two groups. And then we say, as our alternative hypothesis, that they are not the same. We could say that they're just not the same. We could say that one's bigger than the other, but that's kind of dependent on the question. Those are our three options, though. But a lot of times we kind of hang out in this area here of they are not the same. So either they are the same or they're not the same. But the problem here is that our null hypothesis is not now that they are equal some value, some 0.8 or 0.6. It's that they're equal to each other. And if two things are equal to each other, we don't have a numerical value in which we can say is our null hypothesis. Would we use P1? Would we use P2? Would we use 0? In fact, what we use is a combined proportion, a P hat sub C, which is a combined proportion, which is pretty straightforward. It is just the combined successes over the combined samples. We need one value, and this becomes our one value of combined proportions. The good news is that we have still the same three conditions. That it is a simple random sample, that our sample size is 10%, less than 10% of the population, each sample and each population. So if you had 10 out of 100 and you had 15 out of 100, that wouldn't work because this one doesn't work. And the same thing with our greater than 10 large counts condition is that each individual sample size and combined sample proportion multiplication has to be bigger than 10, or whatever the smaller is of the 1 minus P hat sub C. I don't know, we have the same sort of looking equation. We recognize this one here as when we try to combine standard deviations between two different groups. We have our original subtraction, we want to find the difference between those two things. And we find the standardized test statistic, and then we can either use a calculator or we can use our table A. I'll probably do some pausing in this video and use the calculator just to show you, so I don't have to waste time while I'm typing it out. All right, on to an example. I mean, this is really it. This is the example. I might have another one, but I think I'll let you do that one on your own. Let's look at this bad boy here. I'll read it out loud. Oh, you can read it out loud. Pause for a second and read this to yourself. Nice job. Okay, so we have two different groups of students here. We have two low-income elementary schools. We have two different samples. One will be the purple sample of 80 students, in which 19 missed breakfast. At school 2, we had 150 students and 26 missed breakfast. Do these data give convincing evidence of a difference in the population proportions at the 5% significance level? Explain why these samples provide at least some form of evidence. What do you think? I'm going to change my colors here. Hold on. While you're thinking, what do you think? Well, let's just figure out a couple p hats first. Let's do our p hat 1 over here. Is 19 out of 80. I should have done that in purple to keep it consistent with some colors. So let's just change it to purple-ish. Great. Our p hat 2 is, actually, I want to move that down here so we can talk about what the actual percentage is. P hat 2 is 26 out of 150. What are those proportions, do we think? What are those proportions, do we think? Calculate it. There we go. The proportions here are shown, and it looks to me, if I just wanted to explain why the sample results give some evidence, these are not equal to each other. 23.75% and 17.83% are not equal to each other. So there is some evidence for a alternative hypothesis. We didn't even come up with the alternative hypothesis quite yet. Let's do that now that we're actually into it. Because our null hypothesis here is that P sub 1 equal, oops, I shouldn't do this. Our null hypothesis here is that P sub 1 equals P sub 2, and our alternative hypothesis is that P sub 1 doesn't equal P sub 2. This data right here gives evidence for our alternative hypothesis. But now we have to just decide how different are they? Are they different enough for us to not believe that there is a difference? Okay, great. Calculate the standardized test statistic and the p-value. Let's do that right down here. So first we need our combined p-hat score. Our combined p-hat value is the total number of successes. That is the 19 plus the 26 divided by our 80 plus our 150. That looks to be, so I'm just doing some pausing here to make this faster. That looks to be 19 plus 26 is 45 over 230, which is 0.1956. That is our p hat combined value, and I can just plug that bad boy in to our standardized test statistic z-score equals, let's just pause it again. Why not, shall we? Here is the entire thing added up, plopped in there into our formula. Just taking this value here as our p sub c, taking our n1 and our n2 here as our sample sizes. And let's see what that value is. I'm pausing again. I'm going to do this in the calculator. I decided to do it all at the same time here in the calculator because I felt like that's easier to see. You could definitely do it piece by piece, but I think it's easier to do in the calculator. If we hit enter here, we get our standardized test score of 1.078. That is our z-score of 1.078. Actually, I'm just going to say 1.08 because we can't really do a z-score with the other decimal. This is our standardized test statistic. Such great handwriting. Okay, so that means, okay, so if we remember this here, we have a value. This is our standardized test statistic at 1.08. 1.08. And since we have, since our alternative hypothesis is that it is not equal to, we really want to find these two areas here on either side of this thing because of our alternative hypothesis. Our alternative was that it was not equal to, so we want to go on either side. We can use either the table A, or I could just use our calculator and do a normal CDF with 1.08. I will do the normal CDF with 1.08, I think. I'll do normal CDF with the mean. I'm going to do the shorthand. Standard deviation is 1. We'll do lower is negative 1,000 and upper is negative 1.08. And I'm just going to double that. Let's just try it here. So I will go bang, 5, 6, 1, normal CDF 0, 1, negative 10,000 or 1,000, and then negative 1.08. And that gives me 14. Oh, that's pretty good. That gives me equal to 0.14. Now I'm going to, since I want two of them, I'm going to times by 2, and I'm going to get the answer is 0.28 is my p-value. Great. That's part B. Part C then could just say, what conclusion could you make using a 5% significance level? Our conclusion would just be this. Oh gosh. Because, what the heck? What in the world? Because P is equal to 0.28 is less than 0.05. What is it, guys? Can you think about it? Fail to reject H sub 0 that the proportion of students, what is it now, who missed breakfast are the same. There is not convincing evidence. Blah, 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 blah. You can fill in that. Terrible handwriting. I'm so sorry. It's already been 12 minutes, though. So this is too long of a video. There is not convincing evidence. So, yes. Are these the same? No, they're different. But the probability of these two things being different, even if the proportion is the same between those two schools, is 28%. That is a very likely chance that that could happen. It is not unlikely enough that we could get these two samples, even if they are the same. So 28% was our p-value. Now, one thing I guess this question didn't really ask, and it didn't set this up in the plan, state, do, conclude business. But we could just get this out of the way here. And I know you can't, but I can. We could definitely have some conditions here. So let's just say conditions. One, that was a simple random sample. Great job. Two, that it was, did you say large school? Does it even say? Too low income school. Doesn't really say now, does it? But you could just say that n sub 1 equals 80 is bigger than 10%, and n2 of 150 is bigger. Sorry, not bigger than. Oh my gosh. That's the state of mind I'm in right now, guys. Sorry, I'm suffering. Less than 110%. What is going on? I should just start over. Not the video, the day. And then our third one is that our combined, let's see, so it'd be like 80 times 1956, or 150 times 1956. This is about 16, which is good. This is about 30, which is good. So those are some conditions. We are going to do a 2-sample z-test for the population proportion. That's the name of our test, a 2-sample z-test for the population proportion. And now, okay, we have a minute here. Let's just figure this out. Let me go back here to our inference app, and let's just take our hypothesis test and let's just do this. Pi 1 minus pi 2, and pi is not equal to. This is a 2-sample z-test for proportion, with our alternative hypothesis being that they are not equal to each other. Let's just do a couple things here. We will say we have 19 out of 80, and our second group was 56. No, what was it? Shoot, 26 out of 150. So 19 out of 80 and 26 out of 150. And our significance level is that, and we'll calculate it. Okay, so a couple things here. We get our P1 and our P2, yeah? Now, we rounded some of these values, and so our test statistic is a slightly different, right? It's 1.16 instead of 1.08. Now, I might have done the math wrong. You can catch me on that later. We do have a p-value here of 0.2426, which is close to our p-value of 0.28. So the result is that we failed to reject our null hypothesis. Fantastic. I'm hoping that I didn't mess up this here in our calculator. Did I do the square root? I think I just undid it. I'm pretty sure I did the square root correctly, but you never know. Let me know in the comments, like and subscribe. You can try this one on your own if you want to. This is the same sort of idea here. This poor guy that looks like Joe Montana a little bit. Try that one out. Otherwise, you have some nice homework to do. I would suggest doing 9.2. We'll have a quiz on 9.2 when I get back this week, because hopefully I am back this week pretty soon, tomorrow, hopefully. Thank you for watching this. I had a short video, but it turned out to be a long video. I apologize. I will see you all shortly.